So let's make a quick recap of what we were talking about in the last meeting, the first part. I got a little bit overexcited talking about either and stuff like that. So yeah, I think it took more time and I took the emphasis of what I wanted to say. That's the part today. But let's just make a quick recap. We have this stringer type that's called either that has some type A and some type B. We usually use these to handle errors, to treat errors and treat data throughout the code. We usually put errors on this side and the expected result on the right side. An example was to be get James engineer say, for instance, 6. If we have, oops, let me just now that's bigger. If we use this function that returns either string or list of strings, the left side is just an error message. The right side is, oh, my display just died again. Okay. The right side is what we were expected. In this case, the function went everything right. So here is our result, but we could have some errors like this. So we got this left side. A way to check easily the result is just putting this left. And here we can access the, oops, sorry. If here we can access this left, if we are on an else block, we can ask the right. But I will show later, this is the not most, how do I say, it's not the way it's designed to be used, but we can do that. And we talk about mapping stuff, like we could have something like 5. Let's put here a result. You get angst safe. If we run that, we will get that first result, right? And we could do something like mapping. Let's join all the results. And if you see here, it's now all the results is perfectly aligned, but we only map the right side. If we put some errors here, it won't be changed at all. And we can map left. We can map left something like cut. Oh no, same example we used last time. Sorry, we do that. Oops. What's wrong here? Expected one argument. I think I have too many parentheses here. Ah, okay. I was writing inside the map function here. Okay. Now, even map left, add concat. I'm just doing very quick because it's just a recap of what we can do with these structures. So here it is, it's map lefted, but it's affected nothing on the right side. But after that, after what we were talking about, Denise and I started. Well, we had a discussion that I saw that I wasn't very clear in some points. For instance, let's suppose we have this example we used the last time. We have a type that's we call list, but we could call something like could call, for instance, box. Anything. When we're talking about functors that things we can map, it doesn't need to be a list or either on an optional. It's all of them. It's sort of we are boxing something. Here I wrote an example. We give an example like a function that takes one value and goes to another. And here we take and we wanted to apply that on our box. So we must open our box, apply the function, put our box back. This is what map does. And one thing that was not clear, that it wasn't supposed to apply functions that return boxes. For instance, I will give an example with promises that maybe will be easier to see. If we have something like const, let's call it plan, that we get string and return a promise of a number. See, promise is just a box that will be real promise resolve as point dot length here. If we call this function here, plan of something contain console.log. If you do that, we have the result we were expected. But if we want to apply a function, for instance, in promises, the then does something that's a little bit magical in some ways, that we can pass functions that goes to a number to a number, and also a number to another promise. It will work in here. That's not what maps does. Map cannot here. If we see what a map does, it gets a function from A to B, not A to box B. So if we have a function called double, just a n number to a number here, we could just put it here on them, double, and it will work out, will be expected to help. But let's suppose we have a function that does something asynchronous, I don't know, even some promise number here, new promise, yes, a.2. We can do that here, and it will work out. Oops, what did I do? What I did? A number. What?
And right instead of a.
Oh, okay. I was just testing you to see if you were paying attention, you know? See, that worked. But we don't do that with maps. We have another function that opens a box and applies a function that returns a box. Here, we are returning a box. And that caused a lot of confusion in the last time when I was speaking, because usually we are always calling functions that also return promises in the real world. And it was not the case of map. We have a function called chain that did this magic. I will talk about it on a next meeting. I just wanted to clear that out. For instance, if we have a promise, we don't do stuff like that. R.map, like p double 1, 2, 3. If we do that, we'll get a list of promises. That's not what we want. Map is not we are not getting what we want when we do that, when we're expecting. See, we have a lot of promises. That's not the result we wanted. Then we could use a promise all, but my point is, map is for sort of, it's not for boxes. Not if this box a promise, if this box is an either. If you are trying to apply a function on an either type that will return an either, it won't work with map. You have to use chain. I will talk about that later. I just want to clarify this before we start what the today's part. So anything about this part that you want to ask before I go to the decoders part?
I didn't get
Hmm.
what is the issue with the promise all on those cases. So instead of
Oh,
using a
no.
map,
The promise all is not a problem. The promise all is what we have to use to be able to use maps in promises. That's what I'm trying to explain. Because map purely doesn't solve the problem of promises, right? We have to put that promise all that will do some magic to we'll be able to just write to be just one promise in the end. I just got an issue here with my display. I will try to do a little problem here. Yes, it's done. You still see my screen, right? Correct or not?
yes.
Yes.
Yes. Okay. So let's talk about decoders. That was the main point, and I think the coolest part that we will talk about in these two presentations, that is a library wrote by the same guy that wrote FPTS, that is this decoder. What's the point of this? In TypeScript, we can't have types on production because it compiles to JavaScript. JavaScript doesn't have explicit types, etc., etc., etc. And we sometimes receive data in our, the endpoint example is the best one, because we receive data from front end of curl call, something like that. And we can't know for sure if the type's correct. So we have to do a lot of manual checkings or using libraries that for us. But in my experience, this one does the best way, because of the same way about lenses. We can compose everything. We can reuse a lot of stuff. So this is what a decoder are. The decode is just a interface with a function called decode. And here we wrote that function, and that function returned an either. That's why I spent 40 minutes talking about an either. So, because here we could have an error if, well, you sent something that was not what I was expecting. Or here, everything went well. And the cool part is, when we write a decoder, we get the type for free. We don't have to write several functions to decode everything we want, and then write the type again. We have the two at the same time, and I will show you. I will write a decoder from scratch using this, but I will say in advance that's not something that we usually do. But let's give here an example. For instance, let's create I'll just copy this here. Let's create here an enum, and we want to see if we are getting some elements of this enum. So you will be like enum decoder xt.decoder. Let me just import this. Oops. Okay, decoder. We don't know what we're receiving, right? And we want it to be some element of A. So as we saw here, we must write a function called decode. So we have some elements, we don't know what it is, and we want to know if this is one element of these enum. Let's use our pipe here that we love so much. Let's get the values of the enum here. And then let's check if our, sorry, includes our elements. So this is a standard way, like really checking if some, here we get lists of all these elements here, and if you check if it's there or not, and then it returns a boolean, and we have to use the dot success. We will return our element. Just for type safe in here, we do that, asserting. Otherwise, we return a failure element. Let's put this here, and we will understand why I put this text here. As I said, we almost never will do that. I just want to show you how it's done from scratch. But you see in the next examples, let's see this working. Enum.decoder, we have decode. Let's try to decode this. We got a left here. And as you can see here, we got a weird left error. And you can see it's leaf and stuff like that. We don't have to care about that. Because what's happening when we have structs, like objects, there are trees, right? You have a root element, and you have several keys. These keys might be objects, so it's like a tree-like structure. So almost everything we do is parsing an object. So it's sort of it will return a tree of errors, but we don't have to deal with that. They have a function called d.draw here that do the magic for us. And to avoid to write this every time, I wrote a decoder function that does that for us. I would just copy here. What it does, this error message. This is just a map left. So if we get an error, we apply this function. Else we decode the object. So the magic is this. We're using this function, decoder. We're passing our decoder that we wrote. And after that, we try to do that. So if we do that, if you see, now it's the way we're expecting. Like cannot decode this, should be an element of A. This is part of this draw function. So it says he cannot decode. So imagine you got this answer from the backend. You know exactly what went wrong. So I cannot decode this. It should be an element of A. Or I could put a better message here. I could put I could list with I could join all the values, etc., etc. It's just an example. And we got this. Let's put correct result here. It's right. It's safe. It's what we are expecting. And if we see the type here of this result, it's either string, that's an error message, or A. See, we have the type. But let's go to better examples now. So I will let this function here. Okay. This looks like an ugly because I have a lot of types here, etc. But if you see, it's just, the function is just this line. I'm just mapping left. Well, I don't know where I should put the ing here. I'm just map lefting a function that gives me a pretty error message. That's just it. No further magic, just this. The magic is on the code itself. If you see here, we have some primitive decoders, and we have some combinators that we'll use. These primitive decoders, that's why I said we don't write decoders, because we always, primitive decoders are number, string, lists, array. I prefer to call list because I'm a whisper. So lists and everything. You have these basic decoders ready for us. For instance, let's decode like dot number. Number. If we try to pass here, it will give us a right result. And if we pass a string, cannot decode this, should be a number, right? So we don't have to write basic codes because we have it done. And what we can do with this, we can compose, we can refine, we can do a lot of stuff that's very useful. For instance, let's suppose we were waiting for an integer. Integer is a very specific kind of number, and TypeScript doesn't have the difference. But for some reason, we want that in our application. We need that the number we're receiving must be an integer. Let's write a decode for that. Let's just here, my small monitor here. Okay, let's write into decoder. We don't have even to write to worry about those types d dot decoder, d dot that, d dot etc. etc. We don't have to worry about that. We can just pipe stuff. I don't know if you remember in like 2 talks ago, I said that different libraries implemented pipe in different ways. For instance, when we're talking about lambda, here we write the first function, the second function, the third function, and here is the parameter for the first function that will be passed the result to the second, to the third, etc., etc., etc. And I said that I actually find this peculiar choice because in every language I see piping. Piping is usually something like that. Is a parameter. After the parameter, the first function, and the second function, and the third function. I understand why they did that. They sort of create a reverse compose to return a function in the end that you apply the parameter. The FPTS uses pipe this way. Let me just import here. Use pipes this way. You first pass the first parameter and the function, the function, the function. I will use this here just because it's how it's in documentation, but we can make small changes and make it work with the piping lambda, I guess. I didn't try, but just changing the order of stuff. In my opinion, this is more obvious is not the word, it's more intuitive. So let's not focus then on the pipe order, etc., etc. Let's focus on learning the magic of decoders, and in a way we solve that later. Okay, so let's write an integer decoder. What is an integer? So we don't have to write all of this boilerplate. Integer is a number. Oh, okay, so it's number. Okay, now if I try to use this the way it is, it was just that way. Like if I do decoder, it's decoder. If I try this, it will work. If I try this, it will work because this is a number, right? But we don't want that. So what we can do about this? First, we need to know if it's a number. We already know. And then we have the magic called refine. Refine, we receive a function here, for instance, n. We already know its number. And we have I don't remember, I think we talked in the last part, maybe on the discussion, that's type assertion. TypeScript having some functions like n is a number, but we have to worry so much about that. It's just TypeScript stuff. And I already created a function called isInteger. Let me just show you. It's just compare this if n is equals to n rounded. That's a workaround to see if a number is an integer. So we must, here, the point is, in this refine, we will always apply functions that return Boolean. So we want to check if is integer of n, okay? We apply the function, and here we will put an error message. Do you remember that using this, it will already put us cannot decode blah? It should be so an integer, right? Once I did something wrong here. Okay, missing one part. Okay. If we see that now, cannot decode 10.9 should be an integer. That was what I expected. Here it worked. Here it will depend of your in the end we got the 10. Although is this an integer or not? I won't get on this debate. The point is if we try to use we get 10. That 10 is an integer and we can do everything we would expect if we would need some integer. Okay, let's write another decoder. For instance, let's suppose we need to get an UUID. So let's write a UID decoder. So the same, let's pipe first. What's an UUID? It's a string. Let me just show you something cool first. Here. What happens if we pass something like that? That's not something that's not a number. What do you think it will happen here? If we pass a string, anything that's not what we were expecting. Hello?
Would be left, like a left with a
Yes, but
message.
what error message do you expect? Okay, I will answer.
Not sure.
Because here we have this pipe, right? This is returning an either. This refine does some magic that gets this either value and apply here in this new function and will return us an either. So if this is not a number, it won't even be able to get here. Because to be an integer, we must first be a number. If you don't want that behavior, you have to write the int decoder for yourself. But in this case, it will return should be a number. And because here's on the pipe, but if we just do something like that, we get a second error. If we refine most, it should be a positive integer. Well, let's do that. Let's do that. Okay, instead of the like const positive number, positive decoder. That's the magic. Do you remember composing lenses here? This is this is a decoder. The type of this is a decoder. Can you see down there in my screen? It's a decoder. And the type of this is a decoder also, right? So we can refine it. We could refine here that are refined, but maybe we want some, at some point, we want interdecoder, decoder, but at some point we need also a positive decoder. So we can just do this. This is int decoder, and the dot refine, and its number, and bigger than 0. Here a positive integer, right? And now, if we apply here, positive integer, decoder, sorry, we won't be able to get on this refine because it's not an integer. Here should be an integer, but if we pass this, should be a positive integer. So we can compose and refine and refine and refine how many times we want. We could refine here if we don't need an int decoder, so we don't have unnecessary decoder. And we can do this here. And now we have some magic here. We can get, no, I will get typed later because now it's too obvious, it's too simple, it's just a number. Let's just get a second example here. Here. Let's write some UUID decoder. We know it's an integer, so mostly we will be doing refines for simple stuff, and then we'll use something called struct for objects. That's my next example. Let me just write this so we can use it later. Until now, is everything making sense? As a string. I will cheat here. There is a function from a library that do the magic for me. I don't want to write complex regex. So a valid UUID. And we try to apply this. UUID. Let's say here. It's right as we expected, but we take one character. It's left. I cannot decode. This should be a valid UUID. Okay. Everything fine until now. Let's get to another cool stuff here and end it out. Questions? No? Nope. Okay, so let's get more exciting stuff. Let's write a user decoder. A user decoder will be, we call it struct here. Let's say our user has a name. A name is a string. If you want a more refined string, if you want to say, no, it cannot have spaces, cannot have stuff, we just refine it. We create here a name decoder, refine it for a string. But if just checking if the string is fine, this is fine. So let's say last name, also a string. Can you see the resemble of writing a type or an object or an interface? So it's very easy to do that. Email, oh, I didn't write the email decoder. Let me just, I will just copy here. I have it written. There is no different magic here. It's just like UUI decoder. I would have this function that checks the regex to see or rejects. I have no idea how I should pronounce this. So we check if this email, this returns a Boolean, as you can see in the type down there. So I can refine this way okay, here. So here's our email decoder. As you can see, everything we are building here, this decoder has the same type. So I can refine everything because the refining is expecting a decoder and returns a decoder. Here, this is the decoder, this is a decoder, right? This one we wrote here is a decoder. As we can see, the type explicitly written here. So I can refine this enum decoder. So let's suppose we have this enum, but we don't want the A here for, I don't know, right? We can refine. Everything here is that we wrote until now are decoders. So we can refine them, we can combine them, we can do a lot of stuff. I will show you here in this presentation. And let's see, we have this UUID decoder, right? So
Just have a comment actually. I think refine is a, I don't know, the first time you showed it, I was expecting other thing, but in the end it's just a type checking that refine is doing, right? So
yeah,
he's checking the type and then throwing an error. It's like if we, I don't know, like other libraries that does type checking, you can treat like that. So refine is basically type checking and throwing errors in case the type is not correct.
yeah,
Right.
yeah.
In a nutshell.
Yes. I think the refined word gets the idea that I have a decoder that's very broad, like this number. Number has accepts a lot of a huge variety of values. We can pass negative values. We can pass non-integer. Can pass zero. A lot of stuff is number, but integer is a very specific kind of number. So we are refining this decoder. This decoder now accepts more stuff. He's more refined. He's more specific. It's like when we put another lens in our telescope. It's following the example of random lenses. Before we were seeing a much bigger elements, and now we're just looking to more specific stuff. Here we accept a lot of stuff, but here we will accept fewer. And this is the same way. String is even broader than numbers, I think. Thinking about computing, but UUID are very specific ones. See here, I just removed one, and I think this is,
I got it, but
I
then
got overexcited talking about the objects here. Sorry, I repeated myself a lot of times. Yeah.
The refine objective in the end is just a way of, it's like a function that receives a string, for example, and will check types on it. And in case it's not compliance with the type that you want, or in this case, it's not just about types, but about formatting or whatever validation, it will return an error. So, but the name is for me, is a bit misleading because, of course, in the context of the library, refine might be sense, but in the end is a function that is going to make a type checking or a structure checking.
Yes. Okay. Let's test our user here. Let's say we have a name. I will do this for our Argentinian friends. Won the cup. Messi. Email. Let's say we just have any string here, and then now you understand the tree-like behavior of the error message. And ID, let's put a valid UUID here. I will show you first, although we won't use it, the standard error message here. Like, let's decode our user. See, we have errors here inside, right? Because it's a tree of errors, because now we are dealing with the tree. User is a tree of data. And when you use that handling function we wrote over there, user decoder of our user. See, look how beautiful is this. Required property email cannot decode blah should be a valid email. And we have let's put tree.cut. Now it will work. See, the right is what we were expecting. And let's see the error in another deeper way. Let's make this recursive. Let's say child. That's struct. Let's just say it has a name. That's true. I usually put it outside, but just for us to see. And let's say it has a child, but we pass age. Required property child, required property name, cannot code undefined, should be string. And I now got this opportunity to show something cool. That name, I don't know the name of his kid. Message child. I have no idea. I'm not that fan of football. So as we can see here, we have not this age. It suppresses the unwanted information that we might get. The required property is name. So if we don't get this name, we will throw an error. Not throw an error. That's not the word I want to use here. We'll get the left side of we show that an error occurred. It was not what we were expecting. And if we have more information we don't want, we won't be able to access it. If an example here, let's put this on a variable. If it is right of our result, let's put here. So here is what we have. Now we have all this information that we wanted, and the child, we have only name. If somehow the front end is sending a lot of garbage we don't want, no problem. We won't need to deal with that, with a bigger structures inside our application, right? So I will delete this just to okay, let's get this way. And now the cool part, remember when I said when we write decoders, we have types. I was referring more than this, because this is typed, right? We can access name, child has name string, name is string, but we can get the type. The type, we can put it something like that, user, the dot type of. It's a little bit uglier, in my opinion, this type of, but we have to write it once. So we can do this. Now, if we have a function that's waiting for a user, we can use this type. For instance, let's suppose we have the const add user. So we must have our user and promise void, I don't know, something in our backend application to store in the database or something. We have the type. And we can use this. We can apply, right? For instance, we have this add user. Let me just put this here, so start. See, no type errors. It was expecting a user, and we get a user, right? So we have a highly composable and stuff. I use the word composable, and we have a d.compose that will show you the next part here. We can reuse a lot. Why we have to write email decoders in every function, etc. I have this here. I have this here. I can use it wherever I want. I can write bigger structures that use everything here is a decoder. Remember, see, this is decoder, 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 decoder. Even this is a decoder. That in here is a decoder. If you see struct down there, okay. See, d dot decoder, the type's a little bit, a lot of brackets, but the end a d dot decoder, right? Any questions until now?
I think you already touched on this, but when you gave the example of wrong data on the user over
Mhm.
there, so it returns left. Any on the second parent over there left, I think you received a string. Is it possible for you to map which error it is? So like a really basic example is front end is there's a form and then users fill in data and one of the fields is wrong. So I need to add an error just to that field. So I need a way to map it correctly.
Hmm,
Maybe you already
okay.
showed something like this. I'm not sure if you did, or even if it's possible.
Okay, okay. Well, I think it's possible because it's a string. We could do that in two ways. Let's give here an example again. Let's put some wrong stuff here, right? And let's say here we have toys. The kid knows have toys, and it's a struct. I'm just whitening, differing the type here. Must have a name. Okay. Now we will get some errors here. That's required property child, required property named. So this is very human readable, but might not be software readable. We could regex this somehow to get what we cannot decode, right? Or doing the required property name, or we can do no user decoder. I never did that, so but it will be possible. But to be honest, yeah, let's see. I decode user. If you get this strange message, let's put here. Fine.
That
See.
looks promising.
User and user decoder code and dot map left error JSON dot string I am. Let's just see the full tree here. I think this will work. See, this is a weird structure here that we won't be if we want to get everything properly, we would have to study a little bit this FPTS tree. The documentation of FPTS, I don't think it's the best comparing with Lambda, for example, that has a lot of examples, etc. But here we have a lot of stuff we can do with trees and stuff, because this is that exactly same structure, because it's the same person who wrote FPTS and IOTS. So this is a tree. Since this is a tree, we could do tree stuff here to get the leaves and the stuff we want. Maybe not the best approach. I don't know. I might do that. I will try, but not now because
I think with
didn't
the
read
other
this stuff.
example,
Yeah.
I think with the other example that you showed, it was almost there. So you had like an object tree that maybe I think you got like which key failed, and then it was
Uh-huh.
required, and it looks already mappable instead of having
Yes.
to work further with it. So yeah, I think that answers my question.
Yeah. We would have to do a little bit of treating those errors to separate it on its stuff. But it's doable. It's doable in this specific case. It's nice question. I didn't thought about that. But I think doing that this to with that IO decoder user decoder user. Yeah, I think here if you have just if it were printed one line below, it would be perfect in the tree-like form here. But yes, you are nice point. Now the last example, I took Denise's idea and wrote an API like so we can test. But before that, I just want to show you a cool stuff that's called parse. Because in all these example I gave, I did nothing with data, right? Let me just remove all this stuff here because I want to use this type after. We didn't change anything. If I try to decode that, IO decoder, user, here I got it right, so ignore that. We will work with this. I didn't do anything with name, last name, email, ID, nothing. I get the same data as I sent. I just verified that was the data I was expecting. But it's not always the case, right? Sometimes we can have stringified JSON in our object that's coming. That's quite common if we use Amazon stuff. Pretty sure we know a lot of this pain. So let's write a parse here. Const JSON parse. This is a parser. This is not a decoder. I will have a string, and I will copy. Sorry, I don't want to spend time writing. Oh no. This is a decoder. Yes. See here I wrote a decoder by scratch. We would just do that. We have receiving a null and parse. Okay. Probably like record string unknown, right? Or not? Okay. Let me. See. It's any. Okay, because JSON parse returns any, not an object. Right? Okay, so we wrote instead of return the parsed one, we return if it's a success because it's writing from scratch here. I said that we wouldn't do that, but I just bit my tongue. Here, which failed should be a valid string file JSON. So we can now create a cool decoder to be used. Like JSON parse decoder that will be I think that's something wrong with what I wrote here on my notes. To be when we get a string file object, we want it to be a string first, right? We don't want to try to JSON parse a number. So okay. Here's the magic. Parse. The parse, let me show you here on the I won't show every combinator, right? This is the last one, but we can see we have array combinator, record combinator, partial. This is used to get to build structures where we have optional keys. But that's the documentation of decoder is amazing. We can check. So I am on parse. Ah, the last one. The parse, what we will do, we have to combine with something like a string. So we could, in this case, he's trying to parse a number. So as you can see, this is a combinator. Why this is a combinator? Because this is returning a failure or a success, right? So if we return d dot failure or d dot success, as we saw in our type here, it will return a decoder. In this case, he's receiving a string and try to parse to float, right? And if it's not a string-fied number, it gets an error. Otherwise, it will return the number. See, we are returning n. N is the parsed float, not the string. We are decoding unknown to number. And here, we are decoding some string-fied object to a regular object here. For instance, IO decoder, JSON parse decoder, and I got a chat here. I have to go, thanks. Okay, bye-bye. So let's get here an example. String file. Let's put some object here. For instance, let's check if this user is plus. Sure. So as we can see here, this is not a string fight. This is the object. If I do that, as we did before, if e dot is right, a here, a dot right, okay. So, okay, because this is any, but we can try to do this like a console.1, a right, because this is string fight, but this is not typed because JSON dot parse return any, so we don't know yet what we can have here. So let's say plus. True. It's not string, it's not anything. We access it. So we did the magic of getting an annoying string-fied object and putting it into an object that we can access. So let's go further. I'll just comment this. Let's say we have a specific type for this parse stuff we have here. For instance, let's say it's called, this is a very random name, custom. Let's do a custom decoder. And we were expecting it to be a struct that has this plus, and it's d dot boolean, right? Now, if we can, yes.
Sorry to interrupt. We just went past the meeting, so
Okay.
maybe we can close the final minutes now, if it's okay. I don't know how long is the meeting you planned.
No, this is the end. This is the end. I had an API example, but this is the last part. This is the last part. Sorry
Awesome.
about that.
No worries.
Okay. So, okay, we have this and we want to combine this with this other stuff. So let's create here custom data decoder that we've been piping. Let's put our JSON parse decoder that we wrote there. And here is a compose. We are composing like the same way we did with lenses. This is not a refine, right? Because we are not refining stuff. This is, we receiving a decoder and we want to apply another over it. So we will be sort of composing our custom decoder. And now, instead of using this, I will use custom data decoder. And now you will see a dot right dot is plus. Magic, magic, right? And we could do that in our user decoder. So here, let's update our user decoder to have this custom data that we're receiving, that is this user is plus, so true, right? And here we could have this as complex as we wanted, right? So this user is plus. Let me put result. Let's say IO decoder, our user decoder of our user. If we want to see the result, wait, I did something. What's wrong?
There are multiple users, I think.
Ah, okay, okay. Just what's wrong now?
Some upper functions are still using user. Maybe you need to comment those.
Ah, okay.
Yeah, the IO decoder. Yeah.
Man, just because I'm trying to do it fast. Yes. Here, we have name, the. Okay, sorry. Where's our custom decoder? I forgot to see. If we don't have our decoder, we don't want that. We have a custom that is custom data decoder, right? So now this is not string fight. If
May I add
is-
something here?
Yes.
Excuse me. So I really like this and how capable it is. Like you can just handle a lot of different inputs with that, and that I think that definitely can help us in our repository. But I also have a comment about it that I have a feeling, not a feeling, maybe we can also do some research about it, that the functional programming is not well adapted in the JavaScript ecosystem. And you can find a lot of developers, maybe also in our company, that are not adopting it very easily. And so we can just search on lambda functions to see how often they are used in the repository in a way that the functional programming forces us to do. So they are used, like we have some helper function, we use them, but mostly they are not used as the functional programming wants us to be. And for this case as well, like for this library, it's really cool. But I see this problem that it has a lot of learning curves that need to learn a lot of concepts before using it. And if I was going to use a library to only for the purpose of validating the input or some data, I would use libraries that are more close to the current programming patterns that we use in JavaScript. And so this is like general feedback that I have about this library. And so, for example, I would go with AJV, which is a popular library which does this, but this is very simpler. You just define a JSON, and I think it is capable of the same thing that you can do with this library, but it's a much simpler structure.
Yeah, I think the great point of this library, specifically IoTS, not even talking so much about mapping and stuffing with IoT with FPTS, it's how composable and etc. it is. You can reuse a lot of stuff. And as we said, we can always just as you said, we can use for validating, and then the rest of the code we use the data normally. I think that's what we are expecting. First, I just wrote here a small backend application to add a user. That was just a way to show how we could use this in the code base. For instance, for now, this created function is just a function that we return to 201 and the body, right? If we do that, see, creator user. Why is this undefined? Ah, okay, because I don't have a name here. But I'm not validating anything right now. So let's say Lionel Messi. Created user Lionel Messi, but I didn't validate, so we can do this. Let's just very, very quick. So because we are over time here, I don't want to hold you anymore. Let's get this user decoder in here. Oh, let me click on the log here. Let our log there. So yeah, decoder. So let's say we have our user that will be IO decoder of our body, right? No, oops, user decoder of our body. Here we have those either stuff. Either we have an error, either we have what we want. So we could do this two ways. We could do a more imperative way that I was showing, like let's suppose this is left. I have to import here too, either of our user. Let's return bad request with user dot left. So in this case now we know it's right because we are returning the left case. So here we could do this instead of body name. We have a user right name because we know it's decoded. Let's say this, it's running, and this example, created user Lionel Messi. Let's say we don't put this, it will return us 400. Bad request. Cannot required property name, cannot decode undefined, that should be string. And if you see here, we got 400, right? This is a way we can do that. So we check if it's validated, we return 400. And here, after that, we do everything we need. We call any function we need that has the user type here, like our type user.
That's a pretty cool example, I think. So it was good that Denise asked you about like an API, so we know how to use this sort of thing. What I would recommend for you to do maybe is or you can even create a repository for it. It could be in your personal account.
Yes.
Or you can also create a gist inside our own repository, maybe even a repository on our own company. Maybe repository not, because it can be confusing since it's just an example, but it's a good starting point for us to discuss this. So like using a gist, for example, just a simple thing like this, exactly this that you're showing to us right now, can be just with a lot of comments. So yeah, it's definitely a good conversation starter. We don't think we have any validation yet, right? So just like really simple stuff. So yeah, that one's pretty interesting. I also agree with Mohammed, where there are some things that folks need to know while using it, but I can also see the benefits of especially having types like coupled with the validation. I think that's pretty cool. So we don't need to do the work twice, right? We don't need to define the types, then define the validation and fight between those. So that's interesting. But yeah, thanks for the presentation, for both presentations. They're really enlightening. It's a really interesting package over there.
Yeah. So just for finishing, yes, I was planning to put it in a repository. My next talk, I would go further here on this API example, because I want to talk about how we avoid try-catch hell with functional programming instead of putting sub. As you can see, there is no try-catch here in this code, except on that JSON parse part, but it's very hidden, very encapsulated in a function. That's not try-catch here in the code. We check this very purely if this is what we wanted, else we return bad request. And this is, here, let's suppose we have this function here, await, blah, 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 we can do, etc. We can do as we normally do, just using the dot right to access the type we want.